Welcome back. So the bulk of this section is on built-in functions. So there are a bunch of functions that Python gives us we have yet to talk about, and they're pretty helpful. So we're going to kind of go through them one by one towards the end of this section. But the first thing we're going to talk about is kind of a weird topic. It's called lambdas. And yeah, I'll just warn you, up front, it might seem a little weird. It might be startling once we learn what it is and the syntax. And it's kind of a special case of a function. So with that said, let's just dive into it in this video. Okay, so I'm going to show you an example, and you're going to think that it's bizarre. But then I'm going to show you a potential use case, and hopefully it will explain why you would even want to use a lambda. But let's start with the syntax. And the first thing I'll do is just define a regular old plain function like this that we've seen before. And it just returns, it's called square. It takes a single parameter and returns num times num. Right, very simple. And we could do something like print square of 9. And if I execute it, we get 81. Okay, that's totally review. This is a function called square. And it's pretty short. We could just put it on a single line like this, and it should work exactly the same. And it does. But now I'm going to show you a lambda. And I'm just going to write the syntax before I explain it. It looks like this. So this is a lambda that does the exact same thing. You can think of this as a function that has no name. It just exists right here. We could save it to a variable like this, square, let's do square 2. So square 2 is a variable that contains a lambda, which is different. This is an actual function that has a name. This square 2, that function has no name. Some people call them anonymous functions. In other languages like JavaScript, these are very similar to anonymous functions if you're familiar with them. The idea is that it's a procedure we can run, and they're short, one line only, so a lambda can only be one line, and the syntax looks like this. Lambda, always lambda. And then our parameter, and we could have multiple, but if we're just copying what we have here, it's just num or x or whatever, colon, and then a single expression. So we're only allowed a single expression. You wouldn't have multiple lines. And this expression is automatically returned. So we don't use the return statement. And we just do num times num in this case. And that will automatically be returned, the result of that. And to call this, it looks exactly the same. I just run square 2, and then I pass in a number. Let's do 7. I should say, though, this is not how you will typically use a lambda. You won't store it in a variable. I'm just doing this to show you how it works. So if we run this now, we get 49. Okay, so we have two functions that do the same thing. This is a named function, and this is a lambda stored in a variable. We could also define another lambda called add, and do lambda. Let's do a comma b, and then we just return a plus b. So this takes in two parameters, a and b, and then it returns the statement a plus b. So then we could print add of 3 and 10. Just make sure that works. And we get 13. And just to prove to you that our lambdas have no names, if we do square dot, remember this name property, or if you haven't seen it before, there's a name property, and we can print it, 2 underscores on either side of name. If we print it for square, we get square, okay? But now let's duplicate this 2 times, and one time for our first lambda, square 2, and another time for add. And what do we see? They don't have a name. They're just lambdas. They're in a variable called square 2 or add, but that is very different. Okay, so now this all begs the question. We've seen a lambda is like a function. It has no name. It's on a single line. Why would you use this? And the most common use case is when you have some code that actually you need to pass a function into another function as a parameter. And that function will never be used again. So just saying it out loud like that sounds kind of ludicrous to imagine a scenario. What I'm going to do is put us in a little time machine and take you forward, show you some code that we haven't seen yet and that we won't, well, we may understand it, but you shouldn't understand it by default. So this uses a library called tkinter. It stands for TK interface. I think actually most people say TK inter. And it helps us make GUIs, graphical user interfaces, using Python. So I have these comments that say, don't worry about this, don't worry about any of this code. So I don't want to focus on any of this. But let me just fire this up first to show you what it does. It's kind of fun. And it's called button.py, so I'm going to run that. And I get this little window over here. It's kind of hard to see. I don't think I can make it bigger right now. There's a button that says click me. Every time I click that button, I get the text, hello. Okay? That's it. And I'll click the X and it quits out. So all of this code is responsible for importing tkinter, tkinter, creating a frame, creating a button, giving the foreground color, the text on the button, and then starting the button up, starting everything. But notice this code right here. So this is how we make a button. Again, not the focus of this section so far, but it's cool to see. And we pass in a couple of arguments. The first one is where we want the button to be, the frame it's going to go on. Then the text of the button, so we could change that, the foreground color, and then this is the part I want to focus on, a command. And command is going to be a function that will be called whenever that button is clicked. So right now I have a say hi function over here, and it's just a single line that prints hello. So still very simple, but this say hi function is not used anywhere else. It's only used in this one line of code. And imagine that if I had, 20 buttons, and rather than saying hi or printing something, let's say that we're building a little calculator tool with 20 buttons for each number or to add things together, whatever it is. We have 20 buttons. We don't want to define an individual one-line function for each button. So what we can do instead is use a lambda. You might think, could we just do this right here? Comment say hi out. This is what happens if we try that. Hello is run immediately. I haven't even clicked yet. And now when I click, nothing happens. Remember, when we have these parentheses like this, we're executing a function. So when this code is read, this print is run as if it was just down here. So that's also not what we want. So what we want is a one-line short syntax to just tell it to print hello without actually executing it. And rather than defining an individual function like say hi, we can use a lambda. So we just write lambda, and we don't even need a parameter for this lambda, so we'll just do colon print hello. We could put this in a separate variable, but that defeats the purpose. The point of the lambda is that it's inline, and we don't have to make another function or anything. This is a nameless function that just allows us to say, okay, when this button is clicked, run print hello. Run this function, or run this lambda, and all that does is this single expression. So let's verify that it works. Now I click, and I get hello. I didn't capitalize it, sorry about that, but otherwise it's identical. So imagine, again, we have two buttons, and this is button 2, and this one, we can easily just print goodbye. But if we had, instead of using a lambda, we had to do say bye, that means defining a whole other function up here just to use one time. So hopefully you can see, a bit of the utility here. It's just a temporary thing. We pass in a lambda instead as an argument to this button. And don't worry about the button magic and TK and all that stuff. Just focus on this. We replaced a named function with this anonymous lambda. So it's hard for me to gauge how this went because I'm just sitting here alone recording this. I don't have student faces in front of me showing me looks of shock and confusion or vague understanding. I can't gauge it. So if this just made zero sense and you're totally freaked out, the good news is that lambdas are not that commonly used. This is kind of a special situation. There's actually lots of blog posts online of people at one point arguing that they should be removed, that they shouldn't be in Python 3, that there should be another solution, but they're still here. And so I just wanted you to see them. It's something that if I didn't include, I knew I would get some comments about, and somebody would need one at some point and would want to know what the heck they are, because they are weird. But just to reiterate, it's just a single line function that has no name. You can store it in a variable, but that's not something you would typically do. In my slides, there's a couple more examples. We have an add, we have a multiply, if you want to take a look. And in the next video, I'm actually going to show you another common use case for lambdas that's a little less exciting than creating buttons and a graphical interface, but it's also a common use case for them, where we pass them in to another function.